Welcome back. This is an Aleks training video on labeling a typical simple phase diagram. So if you remember phases, you learned them in second grade: solid, liquid, and gas. And solid, liquid, and gas, most of our lives we just thought had something to do with temperature. As the temperature goes higher, ice melts into water, water boils into steam, and then if you were to take away that temperature, the steam would condense back into water, and if you took away more temperature, the water would freeze into ice. Well, it's a little more complicated than that, because if you play with the pressure, you can actually make liquid go into solid, or liquid go into gas, or gas go into solid, based on the pressure. So if you remember the definition of boiling, boiling is when the vapor pressure equals the atmospheric pressure. So the pressure of the vapor above a liquid, where that liquid has escaped into the gas phase, and it's pushing against the atmospheric pressure. Well, as soon as that atmospheric pressure drops, it's easier to boil. So at high altitudes, like high in the mountains, the boiling point is not 100 Celsius. It might be 95 or lower. And if you continue to drop the pressure all the way low, you can make water boil at 60 degrees or 40 degrees or 0 degrees. Okay, so that's called the triple point. The triple point is F on your left hand, schematic is called the triple point, and that's where solid, liquid, and gas are all happening at the same temperature. Solid, liquid, and gas is right there at the same, okay? So look at the right-hand schematic, solid is on the left. If you cross that line as temperature increases, you're going to melt, okay? But if the pressure increases, the higher the pressure goes, the longer that it stays solid, and it doesn't melt until a higher temperature. That's why you've got kind of three lines kind of meeting in the middle. You've got kind of a confluence. The only other thing that you're going to need to remember is the critical point. The critical point is kind of weird. Critical point simply means the temperature can't go any farther to the right than the critical point. The pressure can't go any higher than the critical point, and you still be able to tell a liquid from a gas. Anything past that, like higher pressure than the critical point or higher temperature than critical point, and you've got what is called a supercritical fluid, and it's hard to tell. Is it a gas? Is it a liquid? It's really hard to tell. I'm not quite sure. Okay, it's a fluid because it flows, but who knows if it's gas or a liquid? It kind of has the characteristics of both. Okay, so they're going to ask you some questions. See if we can answer them. So the first question says, if a sample of pure X is solid, in what region must the temperature and pressure be? Okay, well, solid means that it's to the left of the FB line, and so that's region A. Okay, so you would just say region A. Okay, so the second question is, if a sample of pure X is observed to be a mixture of solid, liquid, and gas, what point marks the temperature and pressure? Well, that's called the triple point, and the triple point is at F. So you'd write F. And then the last question is, which is the liquid-gas coesistence curve? Okay, so where does it go between a liquid into a gas? So as you raise the temperature, it'll go it'll vaporize or turn into a gas. That would be the line D. That's the coexistence curve. Sorry, not F. Let's take that away. It would be D. Okay. All right, very straightforward. I think you have no problem here.